but we'll get going here so we can get the things in there that we need to. So happy Wednesday. Enjoy if you haven't been out to sun recently, do that. I was out there the other day and it was just feeling super nice. So it should be a really nice day. We're starting to be warming up and moving toward a little bit more mild weather, which is awesome. Be able to be outside a little bit more. I hope you all are having a good day. If you are a senior, every day this week I'm posting up different things. And so go ahead and take a look at those. There's some trivia questions. There's a senior medallion hunt going on that I'll get clues up for every day. And we're just keeping on moving forward with some things, and a snow sculpture contest. So if you want to participate in any of those things, there's different gift card prizes for all of them. And we're just going to have a good time with that. So if you're a senior, that's something you can be looking for. Look on the senior Class of 2021 page on Schoology. So for us this week, we're talking about series circuits. And so with series circuits, we have several different things that go along with that. And the whole purpose of the practice problems in the lab simulation is for you to have a good understanding of what's going on with that. And so we're going to start with the lab simulation. And so you can do kind of whatever works best for you. If it works well for you to, let me make sure I'm on the right one here. If it works well for you to just watch along and record things and see, I'll talk through all of them. You're welcome to do that. If you want to watch and then do it later, you're welcome to do that. If you want to watch and then watch the video later, that works too. So whatever works best for you, that's up to you. But we're talking about series circuits in the assignments for that. We have our lab, and if you go to the lab, the electricity simulation pops up there. So it'll pop up like this. And then the paper that you're working on looks like this. It's also in that same assignment. And
we can't see your screen right now.
That's helpful. I'm so sorry. Here we go. Let's switch that. I did that last hour too. I started going and then hadn't shared anything. Go. This will be better. So when you go into Schoology and you go into the assignment, so series circuit simulation, you have 3 links here. The first one pulls up the assignment itself. The second one is the simulation. And then the third one is just a video that walks you through how to get started. That if you're, obviously I'm going to do that same stuff right now. So the simulation, when you click on it, will look like this. And with that, the paper that you have, the PDF file, gives you instructions on how to set it up. And so I'll get that set up here. You show the values, you click all of these and make sure you're on conventional current. Electrons actually flow opposite of conventional current. It's sort of a long story and what happens with that. But we talk about it in the way of conventional current, even though electrons flow differently. So that's the difference between here. They flip directions on that. The first thing it has you do is just to set up a standard circuit. So a single bulb, a single wire, or a single bulb, a single battery, and get that lined up here. So it's nothing real fancy. It's essentially what we were looking at last week in the way that those go. One of the things to keep in mind is that when you connect the wires to the light bulb, one wire comes in the bottom, the other one attaches to the side. If you were to take and attach them both to the bottom, it just shorts it out. It doesn't go through the way that they have it structured. They don't have it going through the bulb. And so this replicates what it normally would be with a real bulb, where you have something on the side and something on the bottom. As you're connecting wires, you can see that these wires here, the ends have a red dotted line around them, and the ones up here have a black dotted line around them. When they are appropriately connected to something, that dotted line turns black. So when I let go, it turns black there. Let go, it turns black there. When your whole circuit is appropriately connected, the current will start to flow and it'll show up on there. So you can see the current flowing. You can see that there's these yellow lines coming out of the bulb, and that's indicating the brightness of the bulb. And so on this first one, you have it set up and it just says that, it says to set it up, 9-volt battery, 10 ohms, set it up, calculate the current. And show your steps in your calculation. So show the work that you're doing here. And so with that, we can just say that we're calculating for current. So I is equal to V divided by R. And so that equals, we have 9 volts divided by 10 ohms. In this and in some other situations, the symbol for ohms doesn't necessarily always show up. I know last week on the quiz, the symbol for ohms doesn't show up, which is incredibly frustrating because the symbol on the button to find the symbols is ohms, but then it doesn't appear when you're in there. So you can just write ohms, OHMS, or you can however you want to label that. When it's not available. So I'll usually write ohms that it's in there. So 9 volts divided by 10 ohms gives us 0.9 amps for that first part here of that simple circuit. Then it says to add an ammeter to your circuit. It's found on the right-hand side and measure the current. And so if I go over here and I'm going to just, in order to disconnect a wire, you just click on it. Or you click on the juncture between the two, click the scissors, and it'll open it up. Scissors, it'll open it up. You can just move it out of the way. There's a way, or click on it and delete it. Sometimes that works better than others for some reason. And then you can just connect the ammeter. I like to have my things nice, and it's not going to do that. Whatever. There's our circuit. And then the current here shows up as 0.9 amps as well, which it should. So you can go back, you can put 0.9 amps in here. And move it over into here. So that's all you're doing with this first part, is just getting it set up and figuring out what you have. Number 4 asks you to look at some comparisons. And it says, click on the light bulb. A slider should appear at the bottom of the page. It allows you to control the resistance of the bulb. Experiment with various resistances and answer the following questions. What happens to the current when the resistance increases? What happens to the brightness when the resistance increases? And explain why the change in brightness makes sense. So we'll go back to what we have here. And we're going to click on the bulb, and the slider appears. And then we can change that. You can either click and drag like this, or you can use the arrows to sort of go up by halves. And so we're looking at what happens to the current as the resistance increases. So we're starting at 10 ohms and the current is 0.9 amps. And so when we increase it a little bit, we go up to 30. I just slid it up to 32.5 ohms. My current has gone down to 0.28. I go up to 50 ohms, 0.18 amps. If I go up to 60 ohms, 0.15 amps. And so the farther up I go, the lower my current is becoming. I'm putting more resistance on there, and so that's slowing the current. The other thing that happens is we can look at the brightness. So if we go back to a lower current here, or a lower resistance, we go back to our 10 ohms, you can see that we've got a lot of yellow lines coming out here. That's representing the brightness that we have. And then as we go through here, it gets, as we add resistance, that becomes less bright the whole time. So really, really bright. You can short it out if you want, but it's not real helpful. And the lower the resistance, the brighter it is. The lower the resistance, the higher the current, and the brighter it is. As the resistance goes up, the current goes down and the brightness goes down. So if we go back to what we have on our paper here, it says what happens to the current and the resistance, or when the resistance increases, the current decreases. And then what happens to the brightness when the resistance increases? The brightness also decreases. Well, it says explain why the change in brightness makes sense. Well, we know that the brightness is related to the power. And so more power will give you a brighter bulb. And if P equals IV, if the voltage stays the same because it's connected to the same battery, but if the current is going down, that will cause the power to go down, so the brightness goes down. And that's what they're looking at in this question here. That's what's being trying to figure out here. So because the resistance goes up and the voltage stays the same, the current goes down, so the brightness goes down. So then in circuit 2, it says create the circuit below and draw the schematic for it. Remember, a schematic is just the symbol to the symbols on there. So if I go back to here now, click on here. So you have 2 bulbs and a battery. So all they're looking for with the schematic here is this representation. So you have the circle with the X in it, circle with the X. You got that. That's all the schematic is. A schematic is your straight line drawing using those appropriate symbols to represent what you have. So for the schematic part, this is what you're looking for. So you'll put that in that space over on the side there, back to here. So where it says to draw the schematic, you're putting that there. And then it says when you build it to be sure you include the ammeter and measure the current. And so I'm going to go ahead and build this one here. Go back over here. I'm going to disconnect what I have here, put in another bulb, move things along, disconnect here. Let's do some moving for a moment, see if we can get all this worked out. And put in another bulb. Remember, so when you're connecting a second bulb, it'll go from the side of one to the bottom of the other. So this wire comes in the bottom, goes out the side. The side goes to the bottom, and then you have another wire that'll go out the side. So let's stick this here, goes out the side. So the current goes through the bulb and not just by the bulb. So we can set this up here, set this up there. And we have it connected, so we have our current that's traveling through. You can see that the arrows slow down quite a bit. I have a huge resistance there. That's not what I need. Should have them both at 10 to start. So if you're doing this and you just add on, make sure that the original one is 10. But the current slows down. You can see that it asks what the current is. The current is 0.45 amps. So here's our current. Just gonna take this, move it over here. It was 0.9 amps. When I added on another bulb, I have 0.45 amps. Like that. And then it says use the voltage and the current to calculate the total resistance. So we take this time we're looking for resistance. So we can say R is equal to V divided by I. And so our voltage is still 9 volts divided by our current of 0.45 amps. And that, if we take 9 divided by 0.45, we have 20 ohms. So that is our total resistance in this circuit. If you look, you should have 10 and 10, same thing. 10 plus 10 gives us 20. How does the current in the second circuit compare to the first? Well, in the first circuit, we had 0.9 amps. In the second circuit, we have 0.45 amps. And so it has cut in half. How does the brightness of the bulbs compare the first circuit to the second circuit? That one, if you remember, kind of have to remember back, you can build it separately if you want. It gets kind of tight, but the brightness goes down on these. If you were to compare it to a single one, actually I can do that real easily here. Let me do this. If I just do this to a single one, there's the brightness of a single one, and you see how far those go. I don't have it going through the second one right now. If I bring this back, oh, now I've just got a mess. There we go. And that brightness is not as high as it was. So the brightness goes down from the first one where you have a single bulb connected to where you have 2 bulbs. Then it says click on the bulb on the left. When the slider appears, shift this slider so the bulb has a 20 ohm resistance. So what's our new total resistance? Well, we'll have a 20 ohm and a 10 ohm. So 20 plus 10 is 30. We can put that down. That we can calculate pretty easily. And then what's the new total current? And then we'll use the voltmeter to measure the voltage drop across each bulb. So let's go back to what we have here. We're going to get the slider, go up to 20 ohms. So our new total resistance is adding up the 20 and the 10. Our new current is 0.3 amps. So we were at 0.45 amps, now we're at 0.3 amps. And then it says to use the voltmeter. The voltmeter is over on the right, and you have to drag it out. And you'll set up, you'll put one of the leads on one side of the bulb and one on the leads on the other side of the bulb. Whatever's in between them is the voltage drop that you have. So here I have just this bulb, and the voltage drop on the bulb on the left, the 20 ohm bulb is 6 volts. I move over here. I've got 3 volts for this bulb. The bulb on the right, the 10 ohm bulb, is 3 volts here. Excuse me. So, and if I go across both of them, it's the whole 9 volts that happen to be coming from the battery. So the 10 ohm bulb has a 3 volts drop. 20 ohm bulb has a 6 volt drop. The larger the resistance, the more voltage it'll use up. So you can put these here. Get this, I can say that I have a 6 volt drop. And a 3 volt drop. And the new current is 0.3 amps. So we're looking at how the current has cut in half because I've added more resistance. The bulbs are not as bright because my current's dropped. My new resistance when I change the bulb is 30 ohms. New current, 0.3 amps, and then 6 and 3 volts for the drops there. I want to get the next part set up and a little bit on it, and then we'll move on to a couple of the practice problems that I want to talk through. So this time, the circuit that we're looking at has 4 bulbs in it, and so when we draw that schematic, remember the schematic is the kind of quick visual of what we're doing. So this one has 4 bulbs. And so it looks like that. So that's all we have for that schematic. It might look a little bit different. If you have bulbs on the side, that's fine. If you had like 1, 2, 3, whatever. As long as there's somewhere along here, you're going to be fine with that. So like what I'm saying is you could do, you could have a bulb there. 1, 2, 3, 4, like that. And that would still, this and this are the same thing. Because when the current comes out of the battery, it goes through 1, 2, 3, 4 bulbs. When the current comes out of the battery, it goes 1, 2, 3, 4 bulbs. This one just has a little more wire. There aren't any other paths that can go on. So however you decide to draw that, that's fine. And when we look at this, we're going to click on the bulb and set the resistances to 5, 10, 15, and 20 ohms. So when we go here, I'm going to add in some more bulbs. Put one here. Gotta do some moving here. Sorry about this. So we got 20. Put a 15 here. I'll do that in a minute. 10. I'll do one more bulb on 5. Like that. So, and we'll just put them in order like this. We'll go 5, 10, 15, and 20. 5, 10, 15, 20. Come on. Like that. So we have them set up like that, and it's going to ask about our voltages. And so if we look across here, our 5 ohm voltage is 0.9 volts. 10 ohm voltage is double that, 1.8 volts. 15 ohm voltage here is 2.7 volts. So remember, when you have more resistance, it's going to use up more of the voltage from the battery. And our 20 ohm voltage drop here is 3.6 volts. So they each have a different voltage. If you add them up, it would equal those 9 volts. The next part of the question then asks us to change the voltage of the battery. So we're at 9 volts. It asks us to go to 18 volts. And you can see that on this 20 ohm resistor, now the voltage drop on that one is 7.2 volts. So if we go back, if we go all the way across, we have 18 volts. We go just on the 5 ohm resistor, we have 1.8 volts. We go just on the 10 ohm resistor, we have 3.6 volts. So they're all doubling from what they were before because the voltage on the battery has doubled. 15 ohm resistor, we have 5.4 volts. And the 20 ohm resistor, we have 7.2 volts. And so this one's looking at how that voltage drop. Remember, regardless of what you set it up as, of what battery you put in there, when you get back, you don't have any voltage left. And so that same thing is happening here. So that means that twice the voltage is used on each bulb as compared to before. So you set that up, total resistance, add those up, total current is, I think it's 0.18 amps. Oh, before, yeah, you'd have to do that from before, which is 0.18 because this one's 0.36. And then looking at the overall, then it asks you to put in your voltage measurements for the 9 volts, put in your voltage measurements for the 18 volts, and then compare what's going on from the first to the last. So you can wrap that part up later on. Any questions before I move on to doing a couple of the practice problems? Okay. So 2 of the practice problems that I want to work on are the last 2. We take a look at our practice problems. I should have them up here. Yeah. So the first one is just generally about current and voltage within that. 2 and 3 are just solving for the total resistance. So you're just adding up those resistors. 4 and 5 follow the steps that we had, that we worked through before, and it gives you the steps A, B, C, and D. So you can follow those examples that we did before. And then on number 6 and 7 is what I want to focus on here because they're a little bit goofy. So I'll show you my board in a minute. I'm going to write on it for a moment. 3 bulbs are connected in series. One bulb has a resistance of 10 ohms. Another bulb has a resistance of 16 ohms. And the resistance of the third bulb is unknown. So I have 3 bulbs here. 2 of them we know. 1 of them we don't know. We'll call that one R3. And we have a series circuit that is set up. It says that it's connected to a 12-volt battery with a current of 0.4 amps. So if we look at this setup here, we have a 10 ohm resistor bulb, a 16 ohm bulb, and an unknown resistance here. But we know our total voltage and our total current. So the first thing that we need to do is to take and solve for our total resistance. We know that R is equal to V over I. So we can take our 12 volts divided by 0.4 amps. So if we take 12, yeah, it's 30 ohms. 12 divided by 0.4 gives us 30. So that means that the whole circuit has a resistance of 30 ohms. Well, we know that our resistance, RT, is equal to R1 plus R2 plus R3. So in this situation, that means that RT is 30 equals 10 ohms plus 16 ohms plus R3. So 10 plus 16 is 26. In order to get 30, we would need 4. So R3, the one we're looking for, is 4 ohms. That's all we're looking at on number 6. So in this one, we know everything but that last resistor. Because we know our current, because we know our voltage, we can get our total resistance. And then from that total resistance, we need to go back and figure out that final resistor. Any questions on this one? All right. I'm going to erase this one, and then we'll look at number 7. Number 7 is similar in that you have some of the information, but it's a little bit different than what we tend to solve for when we just have resistances in our battery. So in this one, you have 4 or 5 resistances. Wrong thing. This one says 5 bulbs are connected in series with a current of 0.15 amps. The bulbs have a resistance of 5 ohms, 8 ohms, 12 ohms, 15, and 20. So we have 5 ohms, 8 ohms, 12 ohms, 15 ohms, and 20 ohms. So here is our, it says calculate the voltage of the battery. Well, we don't know the voltage of the battery, and that's what we're looking for, but we do know each of the resistances and the current going through there. Because we know that V equals IR, we can figure out the the voltage drop across each resistor. And then from that voltage drop, we know that when we add up the voltage drops, it'll equal the total of the battery. So if I take 0.15 amps times 5 ohms, they get 0.75 volts. 0.15 amps times 8 ohms, I get something else. I don't remember what I get on this one. 0.15 times 8, I get 1.2 volts. 12 ohms times 0.15 amps, 1.8 volts. 15 times 0.15 gives me, 0.15 amps times 15 ohms gives me 2.25 volts. And 0.15 amps times 20 ohms gives us 3 volts. And so if you look at these totals here, each one is you're dropping some voltage across, and if you add them up, you get your total. So I've got 3 volts. If I combine the 2.25 plus 0.75, that's another 3. If I combine the 1.8 and 1.2, that's another 3. So if I add those up, we end up with 9 volts total, and that is the total voltage from the battery. So that one is just getting at the point of that each of the individual voltages is equal to the total. So each of those questions gets real specific into just sort of what the goal is of what we're looking for and trying to get a certain point across. So that's what we're looking at on this one. Any questions on this one? All right, so I'm going to end sharing my screen. Do that. All right, so things to keep in mind. There's a lot of work that's missing at this point. So please, please, please get your work done, get it in. If you have questions, let me know. I have office hours today from 1 to 2. I have office hours on Friday. I don't remember my hours. Second thing, keep moving forward. Again, it's getting nicer out. There's going to be more options for being outside and seeing people and like doing normal life type things. And don't get yourself tangled up by trying to catch up at that point. So keep up on what you're doing. Keep moving forward. Ask questions as you have them. If you're missing stuff from the previous weeks, please do those. We're already in the 4th week of the quarter. So we're approaching midterm, and we're keeping on moving forward. So keep doing what you're doing. Keep doing the things you need to do. Keep coming. I appreciate that. Hopefully it's helpful and you can get some things done with that. get a good grasp around what's happening this week. Next week, we're going to go into parallel circuits. And so the rules will change a little bit as well as what's happening. So keep doing what you're doing. Have an awesome week. And I will see you on Monday. Take care. Bye-bye.